All right. Hopefully this ends up recording and with sound this time. Supposedly I didn't have sound last time. All right. Hopefully everybody can see what's going on here. Here's the notes that kind of reviews what we went over last time, and we're expanding into this new idea as well. We talked about if two parallel lines, all right, if I knew that I had two parallel lines, the symbol for parallel is this arrow that we can put on those lines. And the line that goes through two of them, try and remember, that's called a transversal. That's going to be a test question. All right. If we have this situation, if we have two parallel lines that are cut by a transversal, then we knew a whole bunch of things. We knew that the corresponding angles were going to be congruent. We were guaranteed. So some corresponding angles, 1 and 2 here, are corresponding. If these lines are parallel, we know that 1 and 2 have to be the same. This is referred to as the corresponding angles postulate. So if you remember,
corresponding angles, duh.
Yeah, so and that's what Evan's absolutely right. So the word postulate, you guys got to remember, postulate meant this is something that if we look at it, it makes sense to us. Nobody wants to argue this. If these lines are parallel, the corresponding angles are going to be the same. In the mathematical word, they're saying we should maybe see that and understand it. Okay? We would also know if we have this situation that the alternate interior angles were also going to be congruent. And clever enough, that's called the alternate interior angles theorem. The rest of these are theorems, which means they required some sort of a discussion to try and prove that. All right, so alternate interior angles, angle 2 and angle 3 are alternate interior angles. If the lines are parallel, they gotta be the same. If I know one of them, I know the other one. We would also know that the alternate exterior angles were going to be congruent. And as you probably are surmising now, it's called the alternate exterior angles theorem. But then we had these other ones called, and if you, alternate exterior would be like angle 1 and angle 4. Those would have to be the same. Those are on alternate sides of the transversal, and then they're on the exterior of our two lines here. This is the interior. If it's not on the interior, then it's on the exterior. But we also knew that same side interior angles, they're different. They're not going to be congruent. Angle 3 here is a same side interior angle with this angle right here, which I'll put a 5. Those are not going to be the same. They're going to be supplementary. And I tried to, if you watched my videos, I tried to give you a good way to memorize it. Look at these letter S's. Same side are going to be supplementary. There's alliteration that's going to help you remember that. Supplementary, if you remember, that means that's two angles that would add up to equal 180 degrees. We also had same side exterior angles. That are also going to be supplementary. So an example of same side exterior angles, angle 4 here is on the outside, and I can put an angle 6 up here that would be on the same side of the transversal and on the exterior. What's that?
I have something I don't know if I'm just going crazy here, but it seems like if both the same side interior angles and both the same side exterior angles, if both of those equal 180, well, if that tells me that, what that tells me is that whatever two angles that are the same side exterior angles, whatever two angles are the same side interior angles, given that they're supplementary, that makes, and they add up as 180, that must mean that those two angles are what form a straight line.
Yeah, basically, yes.
So linear pair is kind of also integrated into same side interior angles and same side exterior angles.
Well, it'd be like mixing up two groups of linear pairs.
Yeah.
But yes, I understand what you're saying. But careful, Evan, you might be scaring some people in the room that didn't like this topic to begin with. So this is the main thing that we learned last time, you guys. I'm not even talking about the new stuff. All right, last time. Remember, we talked about conditional statements. As long as I have this hypothesis, as long as I know that I have two parallel lines that are cut by a transversal, then I know all of this great information. I know this. I know these groups are supplementary. It's a bunch of great information. What we're going to do today is really the exact same thing, but I want you to understand that the converse of all of those statements that we just went over, the converse of all those postulates and theorems are also true. Now let's try and remember what a converse is. A converse switches the hypothesis and the conclusion. Our hypothesis last time was that we had two parallel lines cut by a transversal. Well, we're going to switch that up. So let's take an example. We'll take a look, and we're going to look at the converse, and I'll choose one of them, of the alternate interior angle theorem. It's a really big title, all right? Could be intimidating, possibly. But the converse of the alternate interior angle theorem would say, if I actually have alternate interior angles that are congruent, then I have two parallel lines that were cut by a transversal. So all we're doing is reversing everything we talked about last time. So the idea, here's a picture of what I'm talking about. If we're looking at this situation, do we know that these lines are parallel right now? You should say no, because I don't have the arrows that are on those lines like I did last time. If we look at our previous problems, everybody see these two arrows. That's a symbol that tells me my lines are parallel. I don't have that right now, but if I happen to have alternate interior angles that happen to be congruent, if I actually have alternate interior angles that are congruent, then I could know, and let's say I got line P, R, and S. If I knew that I had alternate interior angles that happen to be congruent, then I would know R has to be parallel to S. You're going to see this kind of a statement on your test. And the reason, let's say it was on a proof. You could say, oh, I know the lines have to be parallel because of the converse of the alternate interior angle theorem. And remember, you wouldn't have to memorize this. This would be an option to grab on your test, but you need to know the only thing we're going to use these converse ideas for is to prove that lines are parallel. So we're going to look at a homework problem, if that's all right with you guys. Let me stop my recording.